In this section, we will be comparing slopes of different equations. In particular, we cover slopes of parallel lines and slopes of perpendicular lines. There are 4 different cases of slopes. The first case is a positive slope, and this indicates that the line slants up from left to right. On the graph, the red line indicates a positive slope. If we were to look at an example and solve for the slope, we would find something equaling a positive number, such as m equals 3. The next case is a negative slope. That indicates the line slants down from left to right. And on the graph, it is the blue line that indicates a negative slope. An example of this would be m equals negative 1/2. Next, we have an undefined slope. This will be illustrated using the green on the graph. And if we were to have an example, this would be finding m equaling any number divided by 0. This is a vertical line. And lastly, we have a slope of 0, and this is any horizontal line. If we were to solve for m would equal 0 divided by any number a. Next, the slope of a line can tell many things, such as if 2 lines are parallel. If 2 lines have the same slope, then the 2 lines are parallel. For example, we have y equals 3x plus 8 and y equals 3x minus 4. Both of these equations are in the slope-intercept form. This is shown as y equals mx plus b, where m is the slope, this is the coefficient in front of x, and b is the y-intercept. As you can see, y equals 3x plus 8, 3 is the slope for that line. In the next line, y equals 3x minus 4, 3 is also the slope. And since these are equal, we know these 2 lines are parallel. Now, let's do an example. It says determine whether the line through -1, 2 and 3, 5 is parallel to the line through 4, 7 and 8, 10. We can tell if these 2 lines are parallel by finding the slope of both lines. By using the slope equation and plugging in the points, we find that the slope of the first line is 3/4. Doing so for the second line, we find that the slope is also 3/4. And since both slopes are equal, we know the 2 lines are parallel. Now, we can also look at the slopes of lines to show whether 2 lines are perpendicular. Perpendicular lines have slopes that are negative reciprocals. This means that their product is equal to -1. Lines with slopes that are negative reciprocals are also perpendicular. For the example below, we see that the slope of the first equation is -1/3. And the slope for the second equation is 3. To find whether these 2 lines are perpendicular, we multiply their slopes. -1/3 times 3 is -3/3, which is equal to -1. Therefore, we know these 2 lines are perpendicular. Let's do another example. It says determine whether the following lines are perpendicular. We have 3x plus 5y equals 6 and 2x equals y minus 4. The first thing we need to do is find the slopes of both lines. This time, instead of using the slope formula with 2 points, we are going to get both equations into the slope-intercept form, y equals mx plus b, and look for our coefficient in front of the x to represent our slope. So first we have 3x plus 5y equals 6. When solving for y, we find that y equals -3/5 x plus 6/5. And the slope of this first line is negative 3/5. Now we do the same thing for the second equation. 3y equals 5x plus 12. We solve for y and we find that the slope is equal to 5/3. In order to show that these two lines are perpendicular, we must multiply their slopes. We have negative 3/5 times 5/3. When multiplying together, that equals negative 15/5, which equals negative 1. Therefore, the lines are perpendicular. Finally, if the slopes of two lines are not equal or do not have a product of negative 1, then the two lines are neither parallel nor perpendicular.